Non-constant will reference to of his node cannot bind to an L value of unrelated top node. Hello, prefect. No member name node in A. What do you mean A? Node here is an A. Yep, and we are back at table elements. But I wonder why. I don't know, man. Table elements. Yeah, I guess it's not working then, right? Yeah, we have to do this in a more clean way. Doesn't make any sense. Yeah, it doesn't make any sense. I cannot cast this at all. That's why it crashed before too. Cannot do that. Cannot do that. This whole clause is nonsense. No, 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 no. Hello, Tulip. This is so confusing. Oh my god. Add no memory, yeah. Well, I'm starting to feel it. I'm definitely starting to feel it, man. I don't think this is as difficult as that I experienced that it is. So it must be my old age, but yeah, that is hard to accept, at the very least. And I can also not describe the exact experience. For example, I'm stuck now, right? But why am I stuck? I guess I just don't have an overview. But that sucks pretty much because I'm writing this to get an overview over my Linux viewer Vulkan engine. I'll try to explain out loud what the problem is and how everything works, okay? Normally everyone runs away screaming. I mean, literally, like I have 10 views, I start explaining things and they all leave. But I have hidden how many views I have. I don't see that, so. So first I set up in a namespace. Well, everything is in a namespace CPP graph. And then inside that I have a namespace dot. And inside that dot namespace I have a class node, which is a light object. It just wraps. Yeah, thank you, Brex. So inside dot I have a class name that is just a wrapper around the boost intrusive pointer to node data. So this is, let's say, equal to intrusive pointer to node data, also a dot. And then node data is the implementation of a node in the graph, right? So a vertex in the graph. So if you make copy of node, then nothing changes. You can just move it around, copy it, and then you can call member functions on node, which is just get passed on to whatever, to the node data object that is being pointed to. And then, so this is namespace dots. And then in namespace graph CPP graph. I also have a class node. Now this node is supposed to be used as the base class of things that you want to appear in the graph. So yes, it's exactly the same as that, right? But there is more to it, in the sense that there is more to it, literally. Like, let's say I have a class, let's say everything that, yeah, no, I don't know. It could be, no. Anything that is derived from node just has a label, I think. So you just literally just get a box in the graph. And then one box is one instance. For example, I could have a struct A derived from node. Well, A is then nothing in namespace graph is, but node is. And then I could have a single A, and that could have a label instance 1. So the creation of this node, the first creation of the node, creates also the node data. Literally calls a new node data. So it's allocate.heap, which then causes one such instance to appear, but it doesn't have any label. It doesn't have a label yet. So I need to call on anything that is derived from this node, the graph node, initialize. Not ask, just necessary, and then the label will appear in it. Otherwise you have just no label inside of it. Moreover, if I would make a copy, say I'm making, yeah, I don't know, I'm creating a copy, let's call this A1. Then I don't know where the 1 comes from, because it needs to have some state in order to get that 1, of course. So here I'm making A2. Sorry, we are making A2, which is a copy of A1. Yeah, no, that's a completely different class. I have no idea how the label would change, but maybe the label should just contain the this pointer. So this has a this pointer, and now we have another this pointer. This pointer of the A2. So after doing this, I want to see 2 of these things. So now there is not a one-on-one relationship anymore between this node and that node, because if I make a copy of this node, nothing happens. It just stays a single vertex in the graph. We really want to make a completely new node graph, node data, I mean. So I have to create a new node, new dot node, because we want to have a new thing in the graph. Even though I call it node when I derive from it here. The thing I'm particularly stuck at now is that my struct, well, actually it's even worse. Let's do it differently. I can also have a class or a struct, let's say B, that is, well, I'll call it D because that's what in my test, which is derived from class. So that's namespace graph class, which has a container of A's. So it's just an array. So we have three of those. Well, it's a member of D then. And I want that to show as a box D with a member. So this is D, whatever, or whatever label D has after initialize being called. So we have to create it. So maybe I should do the same thing as above there. So I make a D, D1, give it a label, and then we would get here, say, the label D1, whatever. But it is a class, so you would have boxes inside of it. For its members. Actually, it's also not true. Hey, post bunny. Okay, this is not an array yet. We'll do that below. This would be a member A, say. Let's call it A3. So then this is going to be called, this will get a label A3, right? Can I put instance in here? Still can do that. Now, of course, if I make a copy of D, I will also make a copy of A. So making an A is derived from a graph, CPP graphis node. So making a copy of this node must duplicate everything, including all the relationships in internal relationships. But yeah, that might change this function of the copy constructor. So I guess it's more or less the responsibility of the copy constructor to take care of all of that. I haven't even tested this. I went straight to arrays, which have their own problem. So in the case of an array, at least in the case of a utils array, I should say, not in the case of a standard array, but in the case of a utils array, we have a third argument here, which is some kind of type. We call it a index here. And I want all arrays that use a index in the same box. And yeah, it immediately shows that you cannot put it inside D1, because if you would make a copy of D1, say, like the whole thing, make a new instance here, and then this would be yet another instance. You want to be kicked out, A4? Oh, so I'm gonna call you A4 for a week. Uh, let's say D has a now also an array, so another member. That array should show as a table. Where's my dot? There. So an array of 3 elements, and this is yet another A. Let's give it a label. This would be AS0. But this whole array would be would be a member of D1, right? So I do need some kind of edge that is going to point to it. This is a member. This is a member edge. But the whole thing here is inside another box. So if we made a copy then also of this member of the whole array, we would have made a copy. And that instance, that table instance, then is a member of the copy. To get something like this, not an arrowhead here, but let's use a special arrowhead. M for member. The reason being that now all these things here are on the same column. So you can add, let's say here, something that has index 0, and here we have everything with index 1 and so on. And they kind of belong together because, well, same index, same thing. That's why I want to put them in the same box, even though they are members. Now, if we would put this box, because it is around that one, inside D1, that wouldn't work, of course, because as soon as I add this table, that doesn't make sense anymore. Then I would want to put it in D2. Of course, you could extend the box of D2 to include that. But yeah, it's probably not working because there is also all kinds of other stuff that might want to add all kinds of containers to this box here. So yeah, let's just use an arrow. However, in order to get this label, I need to call initialize on that node. And now we finally get to the real problem. No, I mean, if you thought this is not difficult, right? It's going to get difficult. So now I have a class D with a member that is an array. And I have classes that are not aware of this node, namely stuff in the namespace dot, that implements this table. I have to add this table inside that table, and that's all dot stuff, right? I mean, so this thing here is implemented in dot, and in namespace dot, and so are these tables. There's my ASCII art. Okay, is anyone still with me? Wow, I have 6 viewers. So now I'll look at the source code, so you can, if you have this picture in mind, then we'll look at source code that tries to implement this. So here I have my struct D, which is derived from a class, and it has an array. And I need to add this array as a member to D. Now we do that by having these two extra things that have to be part of D, because I can have multiple arrays, right? So then I don't know how many to put in class, so I'll just put them here. And then it's actually not true what I said. Indexed container set is in namespace CPP graph. So this is not true. This is in the current. Those tables are implemented in namespace dot, but this big thing isn't. So this would be dot table node, and then this one isn't. Except that I made a new table node inside, not inside dot, which is derived from a dot table node. Except that dot table node is actually a table node template using dot table node data as template parameter. So by using my own table node here, look at it. We have something where we also have control over the table node data. That's namely my own table node data, which is then derived from dot table node data, but hey, at least I can add a function here if I want to. I'm not sure if that's useful or even correct, but it's what I currently did. All in all, this is literally dot table node, except then that it uses this table node instead of that one. but this one is derived from that one. So yeah. The difference is that if you call data, then you get back that thing, so I can call initialize on it. Anyway, what we do is I link the container AS to that table node. And this link container function is a function of the dot namespace. This is just in dot here, table node data dot. So that works because the actual data data returns table node data in the other namespace, which is derived from this class. So then you can call link container on that as well. Which then creates, however, now we are in dot namespace though, so we can only work with the dot node. It's not even necessary that I add dot here because we are already in namespace dot. And yeah, we don't know anything anymore about the other node. So go back to. So now we are here. We know about this node, but actually a node template. So we don't know about this node, but we do know about a node data that we defined here in this namespace. And that will be this node data, because actually node is what we're actually using is node template, which is then using the node data as the argument. So that would be this node data. Yeah, anyway, so the only thing that I inserted are different types, but the only thing that I really inserted is the initialize member, and dot doesn't know anything about that. So we are not bothered by it, and in fact here we just do stuff that was already defined in the dot namespace, namely linking our arbitrary array of stuff that is derived from dot node eventually. We link that to this object, and then we can add that to a given container set. So that would be the big box at the bottom. Basically, you have to see the table node as the little table. So this is a table node, and then this is the indexed container set. So you have multiple, can have multiple of those inside that. Yep, dus the table node is now linked to a given container, and our container set has that table node in it. But like I said, all of this is implemented in the dot namespace, so we have absolutely no clue about this initialize yet. Oh, that's not even true. This one is implemented in the current namespace. Maybe you can do something with that. Maybe. So what I was trying to do is not do anything with initialize and then do the initialize thing here. This adds it to the class. So if you look at the README, that makes sure that this edge will be there. Currently I'm not drawing that edge, but eventually I'm saying, okay, we have this container. We have a table node and an indexed container set. And this table node now is a member of that class. Yeah. And that's what we do here. So I'm saying a table node, and that is a member of this class. And what I'm passing is the AS table node, which has the initialize defined. And I thought, well, I'll implement that, so that will go right, all right. It does in a sense. If you look at the implementation of this function, a table node member is doing, well, it calls initialize on the table node, and it calls, it adds a table node to the subgraph. I don't think this is correct, by the way. It should add an edge, but okay, whatever. I don't think this is visible at the moment. Let's say this is something like blah 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 at the edge. Now this calls initialize on our table node, which is in the in the bottom namespace, not in dot. In other words, this one. So we call this. And since that table node is derived from a table node template using our table node data, we can call now data to get a reference to our table node data, which has our initialize defined. So I just pass on from the table node to the data object the call to initialize. So we get there, and then here I need to call initialize on all the members of the container. And then it got totally stuck because yeah. The problem is we just don't have the correct class pointers anymore. I need to call initialize on graph CPP GraphViz node, but all I have is .node data or .node, but it's the same thing. It just has a pointer to .node data, and doesn't know anything about that other object that is derived from it. But we know that it should be derived from it. So we'd say, well, then you can do, I should be able to do a static cast here. Back to our node data. If that exists, because I doubt it actually. This inside dot, and then we don't have another one. So what the heck? We made our own table node data, but you did not make our own node data. So if I could do a static cast here, of this node data, back to the derived class, when it would be allowed if I am sure that this is derived from that. Sorry, this is the base class of that. Then now we have no data again, and then I can call initialize on it. Now this is weird enough because this class doesn't exist. Apparently I only added an initialize to table node data. Then how am I initializing my other classes? Like, I mean, I literally have that, right? All these are initialized, they have a label. Many B's and A's are initialized. So they do have an initialize. And then it turns out I added that initialize, to the node class. So we are having here, A is derived from a rectangle node, but who cares? The rectangle node is derived from node. Oh, so I did not define a node data, but I did define a node. Or did I? Because now I cannot find it. Sure I did. Here's my node. I renamed it to node 2 to get rid of it. Okay, so before there was just node then, and so A is derived from this. And that hides a dot node. So yeah, you would say if I derive this node, if I derive this node from that one, so I remove this and I make it a base class, then I can do my static cast from that base class back to the node. But it doesn't help because if you make a copy of node, if you make a table node, then that might or does make a copy of these nodes, of dot nodes. And if I purely make a copy of this dot node, then it has become a dot node, and you cannot cast it back to that. So I just make a copy of the base class, and then you cannot cast that back anymore. So I think that what I really need here is a node data, my own node data, which is done. It probably has to be derived from dot node data, and then get that to work somehow. I guess I also need my own node, and that is then, it can then only be dot node template our node data. It should work, right? And why is this not green? Suddenly I don't have a node template anymore. Graph item. Oh, I don't have a node template. So now this node is nothing special anymore. Although usually I want to be able to call member functions of node data also on node itself, because I'm not really allowed to get access to the node data directly. It's maybe a bad choice, but okay. So in the end it just has to be derived from that. And then I can say add a member function for initialize. What the fuck? Initialize. Yes, because if I call this data is now the protected member function of graph item, I hope. Yeah, this one. And that then returns data, which is the template parameter. So we just get back our own node data, which then has the initialize. So that one. I also need this to be implemented. Add to graph. I think. And worse, this virtual function must be really the virtual function of the class that I'm deriving from. So that must be node. I'm deriving from node. A is derived from node. That must have that virtual function. We can still put it down there. I don't know. I guess so. That means, however, that I cannot access node attributes anymore after we are lost inside node data, because we have no access back to that node. This could be many node objects pointing to this node data object. There's no way to get back to those, of course. That might not be a problem. And I suppose the same thing holds for add to graph, because that requires a node. So if you call add node on a graph, what does that do? That just gets the node data and then stores the node. Wait, this is graph data. If you call add node on a graph, that would be this one. It's a graph template, okay. So that would be this one, but yeah, that then calls, just passes it on to the data object. So that was the other one that we already saw. Well, we already have graph data here. We get graph data and then we just call add node directly on it. And that requires a node. And then the node is being added as the smart pointer, as the boost intrusive pointer to this node here. So the graph only wait, this is a graph item of node data, yeah. That would be a node, as it were. So that's the intrusive pointer. So all that does is increment the reference count on this node. Which means that we need a node, right? We don't have a node. So it seems that also this must be part of that object. And then we don't have a node anymore. I made it a base class, or it is a base class. I don't know. I'll make it this. That would be our node. So by doing this, we just make a copy of this node, meaning we increment the reference count to this node data. And we store pointer to the node data in the graph. Okay, what about these things? Well, I can also not do that anymore. Cannot do that from, you cannot go back to node from node data. So I'm not sure why that is even here. This is just giving access and even casting back, yeah. Almost treating that as a base class, and now it is a base class. So I don't think we need these at all. Now this is the base class of node. You can just treat it as if it is a dot graph item node data. Okay, so the only difference is now that my initialize is now part of node data, so that I can access it again. So node is now derived from this, and that's what we store. So I can cast it back, and we can access node data to begin with. I'm not sure though. It's definitely not going to compile probably, but this might work, except that we call node attributes, which is the virtual function of that bloody thing here. So nope, doesn't work. Hello, Mantra. Is it just me, or I mean, am I doing something wrong, or am I being stupid, or what? I'm going to try to compile this anyway. See where the current problems are. Now, at first sight, I would say that's really weird, because my graph is node is now supposed to be. Oh no, it's not. Oh no, it's not derived from that. So it derives from graph is some node data. So yeah, it's not derived from that, because that has a different template argument. So we'd say then add node is a little bit limited. So which one? That was the graph data. This one. Sure, could turn this into a template. No, the problem is if I really would want to store that whole thing in nodes, let's see, I don't like this. I also have the, the feeling that this should work basically. You should be allowed to convert it, because as long as node is just a wrapper around that boost intrusive pointer, then it should be allowed to convert template parameter. But that then would indeed be a template, or not. It's not. It's a graph item. Okay, so what I'm saying is that probably should allow constructing a graph item from another graph item with another D. No, this is not a... Yeah, well, why not? As long as this works, I would say. So we have to we have to convert probably not necessary. I mean, if this works, then that's already the case, I would say. But yeah, I'm curious anyway. Great. Yeah, just you just put it after the template. Thought so, but no viable conversion from graph node to graph.node. Well, just try to fix that. Candidate constructor not viable. No known conversion from graph to graph item. Constraint not satisfied. D is graph data. Because standard derived from graph data, comma .no data evaluated false. Because is convertible v consolidate blah 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 evaluated false. Yeah, you would think that you have access to other graph item. So only with the same data or something? Other does not have that. So I'll have to add a friend for all the other templates then maybe. Not sure if that is correct. I never know where the friend goes. Partial specialization cannot declare as a friend. Let's try this one. Same thing. Gotta be kidding me. I like this one more. I want us to be a friend of graph item D. But in case data is D and D is data, that would be the case, wouldn't it? But it's not allowed. What? Why? How is that partial specialization? Apparently that worked. A non-const L value reference to type CBB graph is .node. Cannot bind to a value of unrelated type standard array value type, aka A. Let's remove the cost to begin with. So this container returns an A. A is derived from rectangle node, which is derived from node, which is defined as a graph item of node data, and table elements accepts dot node, but dot node is a graph item, node data, which we just extended to accept graph items of other Ds. So, right, yeah. What is wrong? That's the question. But I had added this to fix this, right? So why is it not working? So I did define a node for the other thing. So you have another node here. Let's go back to this node, jump. Where's my other node? Oh, this one, yeah. No, it's not the way we go, I think. Now what? So guys who are looking since last half hour, is it my age? Am I just turning senile, or is this difficult? Because it feels very difficult to me, unfortunately. Maybe I should not an IQ test online somewhere. Oh no, I cannot do that. So it's not going to be spelled. I don't like this kind of. It's not another test. Seriously. Okay, yeah, well, it looks like the square with a filled thing in it. So this one, right? Only 8 questions. That's ridiculous. Okay, so this moves to the left. Oops, end up with this thing, I guess. And this is, well, 1, 2, 3. So this one. That is this one, right? What is this? Remove the triangle. Oh no, it's an exclusive OR. Shoot, it's an upside down triangle. What do you have here? No, it just moves left, so that would be this one. Moves right, I mean. Yeah, what the fuck. And this is an end. So we get an OR, I mean. So stupid. That would be this one. What? Please answer questions below. Mail. Oops, 58. Netherlands. It may be higher. Yeah, it's probably higher. Did I make any errors? That's the question. I don't think I made any errors. See, they don't even tell you if you did it correctly or not. It's ridiculous. But okay, based on this, I guess I made no errors. And now I have to pay, probably. If you want more. Nah, they have to pay. Stupid. Nah, yeah. I don't know, man. I think that the test is way too simple. Can't really test if I'm degrading. Things like that. It's late again, though. I should have to stop. No, I don't think we made much progress. This should have worked by now. Maybe I should do it offline, so I can. It's still a different kind of, you know. No, I meant to type light chess. I'm gonna make a puzzle, otherwise I lose. Oh no, they moved the rook. Check. I have to do something about it, like giving check ourselves. Takes a good to the bottom. Can check again. I can run away all the way up here. So I think that I could do something without a check. As long as we threaten to put the rook here, and then I threaten to give check and then mate. By taking here. Taking here? No, there's two rooks on it. Say maybe move up this pawn and then just threat to go here and then give check a mate. But yeah, this pawn is going to move up and then. And the king has 3 squares. Check, go there, check, go there, or anywhere, or completely away. No, infinite check. Give check and immediately go here anyway. And then what do I have? Nothing. Can give check, goes here. Well, nothing left. I don't see it. Maybe the problem is simply not to lose, because it tried to take this pawn. So I would want to put my rook back, maybe, simply. And I cannot because of that. So say I give check and the king goes there, and then I put my rook back. Hardly believe that's it. How would I? Definitely not. But I don't think you have to win. You just have to do the best move, right? I feel I'm gonna fail this one. But okay, so we give check and then it doesn't want to go there. So maybe it goes there instead. And then I still don't have anything. Okay, to give check again. Goes back. Okay, we move this pawn up. I feel like they have to make a hole here. But if they do, I can just take en passant. Or I can just take directly. And that's definitely nasty. I would like that. I think I'm gonna move this pawn. Let's move this pawn. So scary, but that was the right move. Yeah, but now we have to run away from infinite check. So I can walk this way. Or I can walk down and then up here. Now this one is going to be very, very quickly on the other side, of course. So I suppose I go down and they don't even give check. They just 1-2 mate. Or maybe first a rook. So I really, really have to threaten mate here. But am I? That is the question. Man, this is equally difficult still. I thought I was going to run here, but now I'm not so sure. Why not just go this way? Suppose I go this way and the pawn moves, or whatever. Then I put my rook here, and now I really threaten mate in 1. So this pawn has to be moved. Absolutely no other possibility. Oh wait, as soon as I put my rook here, they can give check. That's kind of nasty. And then I go here. And then I take that rook at the very least. Okay, then you have to move the pawn. And then I take it, we check. Oh, that's also mate. They can't make a hole. This just threatens mate on 1. Either like this, or if they move the pawn by taking it. So yeah, then I don't have to stop this pawn. I think I'm going to stay away from this line. I'll just go there to king here. If the rook goes here to stop me, then it's mate in 1. If the rook doesn't go there, then I go here, and then it's mate in 1 after that. There's nothing they can do about it. Oh right, this is really wrong. If I go here, then I just give check, and I take the rook, and I take that rook. That's the only move. No! Oh God, no. Why? Don't tell me. What's wrong about this move? Okay, then it could also go down. I had to go down. Why on earth did I have to go down? No, don't tell me that it's... Why? What's the difference? If I go here, what's wrong? They can threaten mate. Then they does this, still does this. Yeah, I missed it. You put the king here and he plays this. I cannot do this because this is mate. That was stupid. That was really stupid. I mean, not stupid, but I was planning like, okay, white does something and then I go there. And I didn't consider this move. Now I cannot go there. Yeah, well, it's a good move. It's a good one. Definitely a good one. And now I want to stop, but it immediately continues. It's so annoying. My queen must go to this file. Cannot attack something and at the same time threaten to go here. 3-0. Okay, how do I accept that? 3-0. Oh my god, that's way faster than I'm used to. Huh? Why? You have to go back to F7, of course. Okay, well, I don't do a rematch because it's late and I wanted to go offline and stuff. But thanks for the game. Assuming you are a viewer.